Good morning, everyone. So what we're going to be doing today is we are going to intro Unit 9, which is going to be all about quadratics. Originally in Unit 8, we did a lot of things about linear forms and some exponential forms, so we will get to that, and if you want to work on some remediation for that, we could possibly do that later this week or next week. But other than that, I want to kind of jump right into Unit 9 and get us kind of prepared for what is going to come this semester. So what you're going to be doing is you're going to be following along with this Edpuzzle video. You can stop the video whenever you want. There will be certain points where I will ask you to stop the video and I want you to actually try the next problem without my help, and then we can obviously go through that at another time. So what I want you to do is go at your own pace. It's okay if it's different than your person you're sitting next to's pace. If you have questions, though, feel free to ask each other and help each other out. Okay, so first, remember the following formula. So we have slope-intercept form. It's a formula, but we call it slope-intercept form. So what we're going to be looking at is y equals mx plus b. So remember, in the slope-intercept form, the m represents the slope, and the b represents the y-intercept. So this is our holy grail of formulas. This will never go away. So we want to kind of practice and remember, how do we find slope and y-intercept from a graph? So again, this is a little bit of a review. So the first thing I want to do when I'm given a graph of a line, and if it looks like this, the first thing I want to do is identify the y-intercept, which is that b value. Remember, y-intercept means where I cross the y-axis. So here's my y-axis right here, right? So I'm asking, where do we cross the y-axis? Well, it's going to cross right at this point, right? And what is that value? Well, we're going down 1, 2, 3. So my b value is -3, or my y-intercept, in other words, is 0, -3, right? The next thing I want to do is I want to calculate the slope. Remember, slope is rise over run, or y over x. So let me erase this. We always go from the left to the right. So for example, to get from this point to this point, I'm going to go up 1, 2, and I'm going to go over 1. So my slope is 2 over 1, which is 2. So if my m, right, is 2, and my b is -3, right, that's where these values are coming from, I'm going to plug it in for m and for b into my formula. So my final slope-intercept equation is y equals 2x minus 3. So now I want you to pause the video and I want you to try number 2. So take a second. I want you to give yourself time for number 2. Okay, once you come back, we're going to get on to number 3. So now try to find the slope y-intercept and slope-intercept equation for this graph below. Notice the graph below is just a collection of points. So we could connect all these points to form a line. And it looks like I'm getting like super close, right? There we go, a little bit better. So what is the slope of these points, right? Well, I'm just going to go from one point to the next, left to right. 1, 2, 3. And I'm going over 1. So my slope is 3. Now the y-intercept isn't exactly shown, right? But when I tried to graph this, right, it looks like it's going to hit maybe 2. Now, in order to check this, to make sure that this is exact, right, we can apply that slope again because this pattern continues. So if I go up 1, 2, 3 over 1, right, that pattern's continuing. The same thing should occur from the left, right? So if I go from this point that I think is going to be the y-intercept, and I go up 1, 2, 3 over 1, right, that pattern continues. So I would definitely say my y-intercept is going to be 2. And again, this is because I'm noticing patterns. Patterns are going to be super important throughout this unit, and especially for 9.1. So then what is the slope-intercept equation or slope-intercept form here? Well, y equals mx plus b. Y equals 3x plus 2. So a lot of these skills we've been talking about before, we've used before, we've seen before. Okay. So now what we're going to do is kind of look at some different patterns. And again, this is going to come in real handy for 9.1. Some of this you're going to have to do by yourself, and we'll kind of do the first one together, number 4, and then maybe we'll even do number 5 together. And then I'm going to have you try number 6, 7, and 8 on your own and see what you can kind of come up with. So let's start with number 4. So we want to build the following growing 2-story apartment pattern with your pattern blocks. So we don't have physical blocks in front of us. That is completely okay. What we're going to be doing is we're going to kind of look at what's happening here. Okay, so we're given figure 1, figure 2, figure 3, and we want to draw the pattern for figure 4 and 5. So the first thing I do, hopefully, if you already know what to do, pause this video. But if you were kind of like, I don't really know what to do. The first thing I kind of do is sometimes visuals are helpful to me. And all of you will see things in different ways. So maybe the way I see it will not exactly work for you. But I also like to use numerical values. So I kind of might fill in the table while I'm drawing things because that can help too. So maybe the first thing I notice visually is I have 2 blocks here. Then I have 2 here, but I added another 2. And then figure 3 is like I kept figure 2 and I added kind of this third extra one. So it's kind of like the previous figure, I add 2 blocks every time. So maybe if we're looking at this, maybe this right here should really be an orange, because what happens is I get 2 more every single time. So I take the previous figure and I'm just adding 2 is what it kind of looks like. Now, if visually that didn't make a lot of sense to you and you didn't really see that, maybe numbers can help. If I look at figure 1, there's 2 blocks, right? 1, 2. If I look at figure 2, there's 4 blocks. If I look at figure 3, there are 6 blocks. So now I can kind of see there's this pattern of adding 2, right? So again, visually, if this makes sense to you, you can draw in your figure 4 right now, right? So let's see if I can draw this in. So it's like I keep my previous figure, right, which was 6 blocks. And then I added 2. And maybe this isn't necessarily drawn to scale. So we're going to give ourselves some grace, try our best. But we can kind of see what's happening here. So there's 8, right? Which makes sense. And then you can kind of see maybe figure 5 is going to have 10, right? 1, So 1, 2, 3, 4, 5. And we really have 10, right? And we can kind of see that this makes a lot of sense. This will not only continue our pattern visually, but it will also finish our pattern numerically, right? So tables can be super helpful to notice patterns. Pictures can be helpful to notice patterns. So, do we notice a pattern? How many more blocks are in the next figure each time? Well, maybe you kind of saw that as we were going through it, that really we were adding 2 each time, right? And sometimes it's more noticeable than others visually, but again, you can kind of see what's happening here. You're keeping your original figure and adding, keeping the original figure and adding. So that's kind of where that comes from. So we're going to use the table in part B and plot the points of the graph to the right. Okay, so my figure number is going to be my x variable. The number of blocks is going to be my y. So what's really important, we're going to label our table. So this is going to be my figure number. And then this is going to be the number of blocks. So again, you always want to label your x and y axes. It's super important. Okay, so remember, all of these are just points, right? So the first point is 1, 2. So 1, 2. My second point is 2, 4. Then I have 3, 6, 4, 8, and 5, 10. Remember, you can pause this video at any time if you need to slow down. And we can kind of see that there is going to be this pattern. Sorry, let me just turn on Do Not Disturb. So we're going to see this pattern of adding 2 every time, or a slope of up 2 over 1, right? So from here, you can kind of see up 2 over 1, up 2 over 1. So when we add the same number every time, that's really a linear slope pattern. That's really where that's coming from. So what we're going to do now is find that slope, which we did. So 2 over 1 is my slope. So my slope is 2. My y-intercept. Now this one's a little bit trickier, but again, we can extend our pattern out. So if I was going up 2 over 1 every time, right, then I can do kind of the opposite. Down 2 over 1, right, which is 0. And if I want to double check that this makes sense, right, I can go up 2 over 1. I still get that same slope. We also conceive the figure would be 0. So at figure 0, I have 0 blocks. So slope-intercept form, y equals mx plus b, which is really y equals mx. And if you wanted, you could connect the dots here and form a line, and that should all work. Beautiful. Okay, so we're almost done with the video. I'm going to do one more with you, and then I want you to kind of do the rest. I'm thinking we'll do B together because it's a little bit more complex. And then I'm going to have you do, so we're going to do 6 together, and I'm going to have you do 5, 7, and 8 on your own. Okay. So for number 6. So we want to draw in all of our figures, and then we want to fill in all the blanks. Okay, so figure number 1, they kind of did for us, but there are 5 blocks. So in figure 1, notice here's the figure number, and this says the shapes, but I would probably write for this number of blocks. It just seems to make more sense. And let's label our axes over here too. So figure number and number of blocks. Okay, so in figure 2, let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. In figure 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so maybe we can kind of notice a pattern here. Maybe you are also someone who is visual and you're already starting to see a pattern where I'm adding, looks like I have like the original plus sign with 4 original ones. And then figure 3 is like the other plus sign from figure 2. And I'm adding 4. So maybe you're kind of seeing this pattern of adding 4 visually. Maybe you're also seeing the pattern of adding 4 here, where it looks like I'm adding 4 every time. And then I can kind of continue that pattern in the tabular form and then draw my pictures, or vice versa. So this way I'm really going the opposite way. So I'm going to get 1, but then if I go from 1 to 5, I'm really still adding that 4. 13 plus 4 gives me 17. And 17 plus 4 gives me 21. Now we're going to talk about this one because the fact that now I have figure 17 in here will make things a little bit more tricky. So we'll have to work on that separate. Okay, but figure 1 should have only 1 block, which again makes sense because again, I'm adding the original figure before it and adding 4 on the ends. And then for figure 4, try your best to draw the picture. Maybe I'll just draw kind of circles instead of squares, or maybe I'll try to draw squares. So 1, 2, 3, 1, 2, 3, 4. Now I'm adding a 5th, and then it looks like I have 3. Oh, I'm going to be 1 short. Squeeze 1 in there, and then 1, 2, 3, 4, and 1, 2, 3, 4. I think I got all of them. And then we can obviously count and make sure it all works. Perfect. Okay, so let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay, perfect. That matches figure 4. Okay. And then maybe we'll make this guy just 1 here. Okay, so now we have a pattern visually. We have it in a tabular form. Okay, so now what we want to do is we want to still find the slope. Well, maybe let's plot our points first. So 0, 1, 1, 5, 2, 9, 3, 13, and then it looks like I kind of go off the graph, which is totally okay, because that pattern continues, so I can use an arrow. So my slope is going to be up 4 over 1, which makes sense because up 4 over 1, right? We're seeing this 4y over x, because remember, slope is rise over run, or y over x. So I get a slope of 4. My y-intercept is going to be 1 because I have the point 0, 1. And then when I write my equation, I get y equals 4x plus 1. Now, this says here, I want my figure number to represent 17, right? It skips from 5 to 17. So I can't just add 4 like I would normally do, because that's going to give me figure 6, not figure 17. Well, remember, all of these represent x. So what I can actually do is take that 17 and plug it in. So y is the amount of blocks I'm going to have. That's the unknown. If I take my 4 times 17, right, because 17 is that number there, and I add 1, I can find, using my equation, the new kind of concept here. So get out our calculator. Oops. So we have 4 times 17. And 4 times 17 is 68. And 68 plus 1 is 69. So at figure 17, we have 69 blocks. And then this x here is just really representing like what would it represent for any variable x, and you would really have 4x plus 1. So it doesn't matter, whatever x is, that's how you're going to find it. And this is really becoming from your equation. So what I want you to do for the remainder of class is kind of fill in these blanks of everything we haven't gone through. So go back to number 2 if you still haven't done that one. I want you to look at that. Do number 5, number 7, and number 8. And then I'll have the answer key posted so you can kind of look at it later on. But please try not to look at it. This will really help you when you get to your Math 2 class, if you haven't gotten there already, when we get to the task. Have a great day, and I can't wait to see